Okay, next up we're going to talk a little bit about circuits. So you should have watched the video from the physics minute about circuits and parallel circuits and series circuits. And then this is just trying to get you caught up on that. And then we'll talk about in the next video how those look different when we start talking about the body and the physiological circuits. So remember, this is our series. So we have resistors lined up towards in a row. So there's only one path that the current can flow. Okay, so from the negative pole, so the cathode, the electrons are going to flow through resistance 1. And then as we cross that resistance, okay, the voltage is going to pass through each of the resistance and drop. Okay, so the current stays the same because there's only the one path for it to go, but the voltage is going to drop. So that first voltage is going to be greater than the second voltage and greater than the third voltage. So each time we run through one of these resistors, we're going to drop. And so if we were thinking about a typical electrical circuit, like each of these could be a light bulb or a radio or something like that. In your body, these are going to be different tissues that are going to want to absorb some of that energy in order to make the physiological response. Our parallel circuits have multiple options available. So the path can go through resistance 1, it can go through resistance 2, or it can go through resistance 3. And this is where we get the idea that the path of least resistance, right? So the electrons we're going to have flow through all of these, but we're going to have heavier flow through whichever one of these resistance is lighter. And so an example of this being when we talk about the body, again, blood and nerves are going to be the things that are going to want to transmit the electrons the easiest. And so usually things that don't have a lot of water content are going to be harder for the current to flow through. And so the electrons might flow more so through the bloodstream than through the tendon or the fascia. But there will be some that will run through all of it. Okay. So in this case with the parallel circuit, because we have those 2 or more routes that are available, the resistors are placed side by side instead of end to end, so they don't have to go through each resistor. In this case, the voltage stays the same as we go through, but the current, the amperage, decreases. Okay, so thinking Ohm's law. So you have the I, the volt or the amperage is going to drop from before the resistance to after the resistance, and same here and here and here and here, but the voltage is going to stay the same.